if we look at the general rules, basically carbon, nitrogen, oxygen, and fluorine pretty much always obey the octet rule. You can pretty much count that the best Lewis structure, if you're dealing with, the first row, they'll always follow the octet rule, unless you have an odd number of electrons, and then it'll do the best it can with the electrons that it's given, for example, NO. And then doublet rule, of course, hydrogen just follows the doublet rule. Boron and aluminum, often less than an octet. If you look at formal charges, those would suggest that it would be stable with less than an octet, and for those two atoms, that's generally the case. And then these atoms here, as the central atom, they may have an expanded octet. If they're peripheral atoms, if you have a chlorine out on the periphery, it generally does follow the expanded octet. But if it does generally follow the octet rule. But if it's the central atom, then it will expand. It's very likely to expand the octet, in a way that minimizes the number of formal charges. So that's the way to approach these reactions for nonmetals that form covalent bonds. Counting aluminum is right on the border of a metal and a nonmetal. Okay, so with these concepts, let's try to draw a Lewis structure of xenon bound to oxygen and four fluorines. So this is not a particularly stable compound, but you can make it. Like, noble gases do react to foreign compounds. They're just not particularly stable, and they tend to fall apart. So you have to be very careful with them, isolate them, etc. Okay, so what's the least electronegative? Xenon is the least electronegative. Everything else is pretty electronegative. So we would imagine that a good way to start would be to put the xenon in the center, and then draw 4 fluorines around. And we're getting more than 4 bonds. We have an oxygen here as well. Let's count up the total number of valence electrons. We have 8 from the xenon, plus 6 from the oxygen, plus 4 times 7, whew, lots of electrons. 42 electrons, we've got 10 that are in bonds, which leave 32 electrons to place as pairs. And so that's 16 pairs. And so we've got 5 atoms that like extra electrons. So let's try placing pairs there. Let's fill the octet of fluorine and oxygen. So we filled all their octets, but we still have 1 set of lone pairs left over. Yeah, there's only 1 place to put them, on the xenon. Let's check the formal charges now. So all the fluorines, those have the standard, valence of 7, minus 6, minus 1/2 of 2. Those all have 0 formal charges. So those seem pretty likely to be happy as is. Looking at the oxygen, it has 6, minus 6, minus 1/2, 2. So that has a minus 1 formal charge. That could be better. The xenon, it has a formal charge of 8 minus 2 minus 1/2, 1, 2, 3, 4, 5, 10 electrons there. So it's 8 minus 2 minus 5, a plus 1 formal charge. So actually, if we want to lower the number of formal charges, we'd expect the most stable structure would most closely resemble this. The oxygen actually double bonded to the xenon. And this will now have formal charges. The oxygen formal charge will be 0. The xenon formal charge will be 0. All the formal charges are 0. Yeah, xenon has an expanded octet, but so what? It has access to those electrons. Okay, so that is the most stable structure we could draw.